In 1981, Cadillac put a computer inside a V8 engine and told it to figure out how many cylinders the car actually needed. The computer processed 300,000 operations per second. It got almost all of them wrong. This is the story of the Cadillac V8-6-4, an engine so over-engineered, so ahead of its time, so catastrophically ambitious that it nearly destroyed the most prestigious name in American luxury. And the thing is, the idea was brilliant. The execution just needed about 20 more years of technology that didn't exist yet. To understand how Cadillac ended up here, you need to understand what America looked like in the late 1970s. Because it wasn't pretty. The country had just been through not one, but two oil crises. The OPEC embargo of 1973 had Americans sitting in gas lines for the first time in their lives. Then, just when everyone thought the worst was over, the 1979 crisis hit even harder. Gas prices doubled. Stations ran dry. The whole country was suddenly thinking about fuel economy, which, if you've ever seen a 1975 Cadillac Fleetwood, was not exactly what those cars were designed for. To give you some perspective on how bad things were, in 1970, you could fill up a full-size Cadillac for about $5. By 1980, that same fill-up cost over $30. The American love affair with big engines was suddenly an expensive relationship. Washington responded the way Washington does, with regulations. The corporate average fuel economy standards, or CAFE, started phasing in during 1978, and they were tightening every single year. By 1981, General Motors needed to hit a sales-weighted average of at least 22 miles per gallon across every car it sold, every single one. And Cadillac was a problem. A big, heavy, V8-powered problem. 1 out of every 17 GM cars sold was a Cadillac. That's a lot of thirsty luxury barges dragging down the corporate average. On top of CAFE, there was the gas guzzler tax. Starting with the 1980 model year, the federal government slapped an excise tax on any new car that fell below a certain fuel economy threshold. The worse your mileage, the higher the penalty. For a company selling hundreds of thousands of cars a year, those penalties added up fast. So Cadillac had a problem. Actually, Cadillac had several problems stacked on top of each other. Their customers expected big engines, smooth, powerful, unmistakably Cadillac engines, the kind of engine that whispered money when you pressed the accelerator. You have to understand what Cadillac meant in 1980. This wasn't just a car brand, it was the car brand. When someone said something was the Cadillac of whatever, they meant the best. Period. Cadillac had been building its own proprietary V8 engines since 1914. They pioneered the first mass-produced V8. Their engines powered everything from luxury sedans to tanks in World War II. The Cadillac V8 was American prestige made physical, but the government wanted fuel economy, and the competition, particularly from Mercedes-Benz and BMW, was showing that luxury didn't have to mean wasteful. Japanese imports were eating the rest of GM alive on efficiency. Something had to give. Now the obvious solution was to do what everyone else was doing. Put a smaller engine in the car, shrink the displacement, sacrifice some power, accept the new reality. But this was Cadillac, the standard of the world. Their customers didn't buy a Cadillac to feel like they were driving a Honda. Cadillac's engineers looked at the situation and decided that the obvious solution was beneath them. They would keep their big V8 and simply teach it to pretend it was a smaller engine when nobody was looking. The concept itself was not new. Cylinder deactivation had been tested on multi-cylinder engines going back to World War II. The basic idea is simple enough. When you're cruising on the highway at a steady speed, you don't need all 8 cylinders firing. You're barely using a fraction of the engine's potential. So, what if you could shut some of them off? Run on 6 cylinders when the load is moderate. Drop to 4 when you're just gliding along. Then snap back to all 8 when you stomp the gas to merge onto the freeway. 3 engines in one, as the advertising would later claim. Simple in concept, nightmarish in execution. Cadillac partnered with the Eaton Corporation, a major automotive supplier, to develop the system. Eaton held a series of patents from 1975 covering the underlying deactivation technology, and they worked with GM's engineers to build something that had never been done before in a production car. The foundation was solid. They started with the L61, Cadillac's existing 368 cubic inch V8, 6 liters in metric terms. This was a D-board version of their 425 cubic inch engine, which itself traced its lineage back to the legendary 472 that debuted in 1968, and the monstrous 500 cubic inch V8 that followed in 1970. That 500 was, and remains, the largest V8 engine ever put into a production passenger car. So the 368 wasn't some throwaway engine. It was the last in a line of absolute royalty, good bones, proven hardware, hundreds of thousands of miles of reliability baked into the design, a TH400 transmission behind it, which was essentially indestructible, a 12-bolt rear differential. This was heavy-duty, early 70s muscle car hardware underneath a luxury wrapper. Everything below the cylinder heads was essentially the same bulletproof big block Cadillac had been building for over a decade. Above the cylinder heads, though, things got complicated, fast. The engineers designed a unique set of cylinder heads with tall rocker covers. If you've ever seen a V8-6-4 in person, you can spot it immediately because the valve covers have raised bumps over 4 of the cylinders. Those bumps house the solenoids. 4 of the 8 cylinders, specifically numbers 3, 4, 5, and 6, got special solenoid-controlled mechanisms mounted to the rocker arm studs. When the system decided a cylinder wasn't needed, it would energize the solenoid, which shifted the rocker arm's pivot point. This effectively disconnected the rocker from the camshaft's action. The pushrod still moved up and down, the camshaft still rotated, but the intake and exhaust valves stayed closed. The piston kept moving, compressing the trapped air inside the cylinder, which acted as an air spring. In theory, this eliminated the feeling of a dead cylinder and kept the combustion chamber warm for instant reactivation. The cylinders were deactivated in pairs, opposite pairs specifically, to maintain some semblance of engine balance. First, cylinders 1 and 4 would shut down, dropping the engine to 6-cylinder operation. Then 3 and 6 would follow, bringing it down to 4 cylinders. The engine would only deactivate once the car was in third gear and cruising, so it wasn't trying to juggle cylinders during stop-and-go driving. At least, that was the plan. Controlling all of this was what Cadillac called the Computer Command Module. This was, effectively, one of the first true engine control units ever put in a production car, and it was genuinely sophisticated for its time. It monitored intake manifold pressure, engine speed, coolant temperature, throttle position, road speed, and a dozen other parameters. Based on all that data, it made real-time decisions about how many cylinders the engine needed. 300,000 calculations per second, Cadillac proudly advertised. To put that in context, a modern smartphone does billions. But in 1981, 300,000 sounded like science fiction. Cadillac even marketed the technology as being derived from the United States space program. That same year, the Space Shuttle Columbia made its first orbital flight. Cadillac was essentially saying their engine computer was in the same league. It wasn't. The new engine was designated L62. It produced 140 horsepower at 3,800 RPM and 265 pound-feet of torque at 1,400 RPM. Not exactly thrilling numbers, even by 1981 standards, but for a luxury cruiser, the torque was respectable, and the promise was a 30% improvement in fuel economy compared to older Cadillac drivetrains. 30%. That would have been transformative. The car even came with a dashboard gauge called the MPG Sentinel, a little digital display that showed drivers exactly how many cylinders were firing at any given moment, along with estimated fuel consumption. Cadillac wanted owners to see the technology working, to feel good about their purchase, to watch the numbers drop from 8 to 6 to 4 as they cruised down the interstate, smugly saving fuel in their 2-ton luxury sedan. The climate control panel could also display diagnostic trouble codes, sensor readings, and even allow manual cylinder pair control. For a mechanic in 1981, this was revolutionary. No external scan tools needed. The car could tell you what was wrong with itself. The problem was that it had a lot to say. Cadillac was so confident in the system that they made it standard, not optional, standard. Every single 1981 Cadillac, except the Seville, which came with an Oldsmobile diesel V8 as its base engine, rolled off the line with a V8-6-4. The Seville could get the V8-6-4 as a no-cost alternative to the diesel, which tells you something about how Cadillac felt about the diesel too. The DeVille, the Fleetwood, the Eldorado, the Brougham, all of them, every showroom, every dealer. Cadillac put all its chips on one number, and then customers actually drove them. The early press reviews had been mostly positive. That's because the automotive media got carefully prepared cars and drove them on GM's proving grounds in Milford, Michigan. Controlled conditions, smooth roads, predictable routes. Under those circumstances, the system worked adequately. Journalists wrote glowing reports about seamless cylinder transitions. What nobody mentioned was that a test track in Michigan is about as representative of real driving as a swimming pool is of the Atlantic Ocean. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. The problem started once real cars reached real customers, and they were not subtle. The computer command module, for all its 300,000 operations per second, simply could not keep up with what was happening inside the engine in real-world conditions. The Eaton-GM partnership had dramatically underestimated the computational power needed to manage the constant, chaotic variables of actual driving. Highway cruising on a test track in Michigan is one thing. Stop lights, hills, headwinds, air conditioning loads, passengers, and the general unpredictability of human driving behavior is something else entirely. The most noticeable problem was lag. When the engine needed to reactivate cylinders, going from 4 back to 8 for instance, there was a delay, a very noticeable delay. The driver would press the gas, and the car would hesitate, then lurch, then finally respond. In a Chevrolet, this might have been tolerable. Annoying, but tolerable. In a Cadillac, a car that cost more than most Americans made in a year, a car that was supposed to represent the absolute pinnacle of smooth, effortless power delivery, it was unforgivable. But the lag was just the beginning. The deactivation system and the throttle body fuel injection couldn't agree on what the engine was actually doing at any given moment. The fuel system would send fuel for 8 cylinders when only 4 were firing, or it would lean out when all 8 came back online. The result was a car that surged, bucked, stumbled, and generally behaved like it was having some kind of mechanical seizure. At certain RPMs, the system would hunt. It would activate and deactivate cylinders repeatedly, searching for the right configuration but never quite finding it. 6, 8, 6, 4, 8, 6. Back and forth, endlessly, like a nervous student who can't decide which answer to circle on a test. And here's a detail that makes it worse. A V8 running on only 6 cylinders is inherently unbalanced. The engineers knew this. The 6-cylinder mode was supposed to be a brief transition, a stop on the way down to 4 cylinders, where the engine would settle. But the system didn't always cooperate. Sometimes it would hang in 6-cylinder mode, shaking the car like a washing machine with a brick in it. Not what Cadillac buyers signed up for. The driver could feel every single transition. So could every passenger. So could anyone standing near the car. The MPG Sentinel gauge on the dashboard became an unintentional comedy act, its numbers flickering constantly as the engine tried to figure itself out. There was also the fuel pooling issue. Because of the throttle body injection design, fuel would collect on top of the closed intake valves during longer periods of cylinder deactivation. When those cylinders eventually reactivated and the valves opened, all that pooled fuel would dump into the combustion chamber at once. The result was a rich spike that caused stumbling, poor emissions, and occasionally a small backfire, in a car marketed as the standard of the world. Then there was the exhaust gas recirculation problem. The EGR system was vacuum-controlled and calibrated for a conventional 8-cylinder engine. When the engine dropped to 4 cylinders, those 4 remaining cylinders were working harder, which meant they needed more EGR. But 4 cylinders produce less exhaust flow and less back pressure, so the EGR valve actually delivered less recirculation precisely when the engine needed more. The result was pinging, detonation. The engine was essentially knocking itself to pieces at cruise speed. Now, let's talk about the numbers that actually mattered to buyers. The promised 30% improvement in fuel economy. In the real world, the V8-6-4 delivered about a 15% improvement. Maybe. And some owners reported no improvement at all. The fuel economy figures for 1981 were essentially identical to the non-deactivation 368 engine from 1980. All that engineering, all that complexity, all those solenoids and sensors, and that 300,000 operations per second computer, for nothing measurable in the gas tank. Cadillac's response was, to their credit, fast. They threw software at the problem. 13 updated PROM chips for the engine control module over the course of a single model year. 13. That's more than 1 per month. Each update attempted to smooth out the transitions, adjust the deactivation thresholds, refine the fueling strategy. Some of them helped, a little. None of them solved the fundamental problem, which was that the hardware simply wasn't capable of doing what the software was asking it to do. Dealers, meanwhile, discovered something interesting. You could disable the entire modulated displacement system by disconnecting a single wire from the transmission's third gear switch. One wire, that's all it took to turn the V8-6-4 back into a regular V8. And that's exactly what most dealers started doing. Some of them did it before the car even left the lot. Others waited until the customer came back complaining, which usually took about a week, sometimes less. A few enterprising mechanics ran the wire through a toggle switch mounted inside the car, giving owners the choice. Want to save gas today? Flip the switch. Want to actually enjoy driving your Cadillac? Flip it back. And without the cylinder deactivation, the 368 cubic inch V8 was actually a perfectly good engine. Smooth, reliable, torquey. Everything a Cadillac engine was supposed to be. The irony was painful. There was nothing wrong with the engine itself. It was the stuff they bolted on top of it. That was the problem. The class action lawsuits came quickly. Cadillac owners were not the kind of people who suffered quietly. These were doctors, lawyers, business owners, people who paid top dollar and expected perfection. Getting lurched around by their own engine was not part of the deal. GM responded with what they called engine value protection plans, 5-year or 50,000-mile warranties that covered any owner, not just the original buyer. That's worth pausing on, not just the original buyer. GM was so worried about the cascading reputational damage that they extended the warranty to second and third owners, too. They sent letters to every V8-6-4 owner reassuring them about the engine's quality and future improvements. It was corporate damage control at full speed. And it wasn't just the V8-6-4 causing headaches. The Oldsmobile 5.7-liter diesel V8, which Cadillac was also putting in its cars, was failing catastrophically. Engines grenading at 30,000 miles, head gasket failures everywhere. GM was fighting fires across its entire engine lineup simultaneously. But here's the thing that most people don't know. Cadillac had already decided to kill the V8-6-4 before it even went on sale. The whole system was always intended as a 1-year stopgap. In March of 1980, GM applied for a carbon monoxide emissions waiver for the 6-liter modulated displacement engine. They asked for a 1-year waiver only for 1981. At a public hearing in May of 1980, GM representatives testified that they were not aware of any GM production models that would use the modulated displacement system in 1982 or beyond. The V8-6-4 was always meant to be temporary. A bridge to the HT 4100, a new smaller displacement aluminum block V8 that Cadillac had been developing in secret and had hundreds of millions of dollars invested in at their Livonia manufacturing plant. The cylinder deactivation system was a way to squeeze one more year of acceptable fuel economy out of the old big block while the new engine got ready. The irony is thick enough to cut with a wrench. Cadillac rushed an unready technology into production as a temporary fix, and in doing so, inflicted permanent damage on their reputation. And the engine that replaced it, the HT 4100, turned out to be arguably even worse. 135 horsepower from 4.1 liters. An aluminum block bolted to cast iron heads, a combination that expanded and contracted at different rates and caused endless gasket failures, weak block castings, oil pump failures, camshaft bearing problems. A fully loaded 1982 Cadillac with the HT 4100 had roughly the same power-to-weight ratio as a diesel Chevette. Let that sink in. A Cadillac, with the same acceleration as the cheapest, smallest car in America, with a diesel. Cadillac owners went from being lurched around by a smart engine that was too clever for its own good to being out-accelerated by rental trucks on highway on-ramps. One enthusiast later recalled being passed by a U-Haul while flooring it through the mountains in his 1983 Cadillac with the HT 4100. The U-Haul didn't even seem to notice. It took Cadillac nearly a decade to recover. The 5-liter engine of 1990 was really the first Cadillac power plant since 1981 that didn't embarrass its owners. 9 years. In the car business, that's a generation of buyers who went to Mercedes instead, who bought Lincolns, who quietly switched to Lexus when Toyota launched it in 1989 with the LS 400, a car specifically engineered to humiliate the Cadillac DeVille, and it did. Meanwhile, 1981 was also the year Mercedes introduced the 300D turbo diesel, an inline 5-cylinder that actually worked, establishing the reputation for German engineering quality that endures to this day. The contrast was devastating. Cadillac was selling cars where the fix was to disconnect the main feature. Mercedes was selling cars that ran for 500,000 miles. The reputational damage from the V8-6-4, compounded by the HT 4100 and the disastrous Oldsmobile diesel, created a perception that Cadillac couldn't build a reliable engine. That perception stuck for decades. The V8-6-4 itself lingered on in one application. The Fleetwood commercial chassis, the platform used for limousines and hearses, kept the engine through 1984. The HT 4100 simply didn't have enough power to move a stretched limousine, so the big block with its finicky cylinder deactivation system, usually disabled, continued to haul wedding parties, and the recently departed for 3 more years after the retail cars moved on. Now, here's where the story gets interesting in a different way, because the V8-6-4 wasn't wrong. It was early. The concept of cylinder deactivation that Cadillac tried to execute in 1981 with late 70s computing technology is now standard across the automotive industry. The EPA reported that about 15% of all light vehicles sold in America used cylinder deactivation in the 2023 model year. GM's own active fuel management system, Honda's variable cylinder management, Chrysler's multi-displacement system, they all do exactly what the V8-6-4 tried to do. The difference is that modern engine control units process millions of operations per second, not 300,000. Modern systems use oil pressure to collapse hydraulic lifters rather than mechanical solenoids on rocker arms. Modern fuel injection is sequential and port-based or direct injected, not a single throttle body dumping fuel into a common plenum. The sensors are faster, the actuators are faster, the computers are faster. Everything that the V8-6-4 needed to work properly simply didn't exist in 1981. There's a small but dedicated community of enthusiasts who still maintain working V8-6-4 systems today. They've found that with modern aftermarket engine management, better sensors, and cleaned-up wiring, the fundamental mechanical system actually works reasonably well. The solenoids respond quickly enough. The air spring effect in deactivated cylinders is smooth. The basic engineering was sound. It was always the brain that was the problem, not the body. Some of these enthusiasts have even discussed putting the V8-6-4 deactivation hardware on the larger 500 cubic inch Cadillac engine, because apparently making the most problematic engine management system in automotive history work on the largest passenger car V8 ever built is someone's idea of a fun weekend project. To be fair, they were warned. If you think about it, the story of the Cadillac V8-6-4 is really a story about timing, about the gap between what engineers can imagine and what technology can deliver. Cadillac's engineers in the late 1970s looked at the future and saw exactly where the industry was headed. Cylinder deactivation, computer-controlled engine management, variable displacement, real-time diagnostics displayed on the dashboard, onboard trouble codes that mechanics could read without external equipment. They were right about all of it. Every single one of those features is standard on modern cars. They were just 20 years too early, and they didn't have the courage, or maybe the luxury, to wait. It's also a story about what happens when corporate pressure overrides engineering judgment. The CAFE standards were coming. The gas guzzler tax was coming. Mercedes was coming. Cadillac needed a solution now, not in 20 years. So they shipped a product that wasn't ready and turned their most loyal customers into unwilling beta testers. Sound familiar? It should. The pattern repeats across every era of automotive history. And not just automotive history, if we're being honest. The 1981 Cadillac with the V8-6-4 sits in a strange place in automotive history. It's a punchline and a prophecy, a failure that predicted the future, an engine that was simultaneously too much and not enough, over-engineered in ambition, under-equipped in execution, the most complicated way anyone has ever tried to save a gallon of gas. 300,000 operations per second, 13 software updates, one disconnected wire to fix it all. That's the Cadillac V8-6-4. And there you have it, the most over-engineered engine ever put into a production car. An engine killed by its own intelligence or lack thereof. If you've ever ridden in one, or better yet, if you've actually gotten the cylinder deactivation to work properly, I want to hear about it in the comments. And if you made it this far, go ahead and subscribe. We do this every week.